Okay, good morning everyone. This will be my last stream because next week is the final week leading up to the end of the school year. And this is like sort of the final bit of content that you guys need to cover. So, in terms of what we're doing today, we're just finishing off our forces in motion topic with discussing machines. And we briefly touched upon one type of machine last lesson when we talked about levers and how levers were related to moments, force times distance. Um, um, so, today we're going to be talking about other types of machines and how they help. So the first thing that we need to obviously cover is basically what a machine is to start off with. And this is it seems quite straightforward because you guys would have heard of the word machine before and already have some understanding of what that means. But in physics, once again, our definitions are quite broad and they're quite vague. So basically, what a machine is it's anything that can help us work with forces. So let me write that out. So as humans, we obviously have a limit to how much force we can carry, how much weight we can lift, etc., etc. So these machines basically help us with being able uh, to have to, to have larger forces or lift heavier things, etc., etc., etc. And mainly in physics, we learn about what are known as simple machines. Now, this was one of your quiz questions if you've already done the quiz before. But simple machines basically are exactly as the word implies, in that they're simple and that they're straightforward. And they're mainly designed only to have like one particular thing in mind. So simple machines such as levers, ramps, and pulleys. Something like a car wouldn't be a simple machine because within that car itself there are a bunch of other machines that are in there to help it do its overall function. So though in that instance, when you have like something complex, that means that you have like loads of different parts that are coming together for one particular function. But a simple machine is basically like a simple tool that has one particular use to us. Now, last lesson we already talked about levers. So, for example, we have a rock that we want to lift, and we have our person lifting that rock. And these levers basically act as force multipliers mainly, in the case that we are taking what is a smaller force from us, and then the lever multiplies it and allows us to move something with a larger force than we are inputting. So like say we're inputting 10 newtons, this machine then on the rock outputs say 20 newtons or something like that. So it multiplies the force that we put in. Levers, though, can also be used in the opposite way, so it can take a large force and end up moving something a larger distance. So it could also be what's known as a distance multiplier. But at this stage, we don't really need to consider distance multipliers much. Just know that they exist. But we're mainly talking about force multipliers here. Now with ramps, let's say that we had something super heavy that we were trying to push up. If we were to just lift it up, it'd be like the pure, we're trying to lift this thing's weight. But with a ramp, we end up needing to use a lot less force in order to push it up to be the same height. Obviously, it will take a lot longer because it has to travel a further distance. But it's once again a case of being a force multiplier in that it allows us to take a smaller force and turn it into a bigger force, if that makes sense. Now, pulleys is basically like we have a rope, and then on one end we attach to one thing that we're trying to lift, and we're pulling on the rope. They also work as force multipliers to allow us to use a smaller force to lift something larger. And we're going to go into these later too, into more detail in a second. But in order for you to fully understand how those two ramps and levers work, you need to know one equation, one formula. First of all, though, let's say we were lifting a box, and that box was 100 kilograms or something, and we wanted to lift it up a certain height. Think back to year 7 now. When we are lifting this box, we are transferring energy to this box, right? We are lifting it up, and because it's being raised up off of the ground, there's a specific type of energy that we're actually increasing. Hopefully you guys can remember, but by lifting it up to become higher, we are increasing its gravitational potential energy because we're lifting it up off the ground. Well, think back to when I mentioned to you guys about the law of conservation of energy. That gravitational potential energy can't have come from nowhere. It had to have come from somewhere. And where it came from was you, right? Because you were the one doing the lifting. So you were transferring your energy to this box in order to lift it up. Now, when you are transferring your energy to this box to lift it up, the way you are transferring your energy is by using a force, by using the force of you pulling on the box to lift it, or pushing on the box to lift it. But the main key bit is you're using a force to transfer your energy, the chemical energy in your muscles and your body, to become the gravitational potential energy of this box, because law of conservation of energy can't have come from nowhere. The gravitational potential energy had to have come from somewhere. And we call you doing this work. Basically, work is just an energy transfer by a force. So when you are lifting the box, we're saying that you're doing work on the box and that you're transferring energy to the box. So instead of always saying you're transferring energy to the box to lift it, we're saying you're doing work to lift it. But it means the same thing. All work is just energy transferred by a force. And the energy that's transferred by a force, how much energy you transfer, obviously it's going to depend on how much force you use. And it also depends on how far that force is acting on. So obviously, if you need to lift a box a greater height, you're going to be needing to do more work on the box. If you're lifting the box a shorter height, you need to do less work. So how much energy you transfer depends on how much force you input and also the distance that you're doing it with. One thing I want you to note though, from this formula, work equals force times distance, is what will happen, the relationship between force and distance. Let's say that the amount of energy we are transferring is a fixed amount, because it's going to, like for example, when this box moves up a certain height, it's going to gain a certain amount of gravitational potential energy. Let's pretend that it gains 100 joules. If it's gaining 100 joules of gravitational potential energy, that also has to mean that you are transferring 100 joules to it, because law of conservation of energy, it has to be the same amount. So when you're transferring 100 joules of energy to increase its gravitational, you're doing 100 joules of work. Now let's pretend that your force to do this with is really, really small. You got weak arms. Let's say that you're only able to input 2 newtons of force to do this. Well, how far would you have to move it then in order to transfer 100 joules of energy? 100 equals 2 times blank. The missing would be 50 for distance. Now, let's think about the opposite way. And this will make sense why I'm showing you this in a second. Let's pretend, same 100 joules of energy that is going to be transferred, of work that's going to be done. Let's pretend that you're super, super strong. And this time around, you input 50 newtons of force. Well, then that means in order to transfer the same amount of energy, you only need to lift it 2 meters. So notice that the relationship of force and distance, they're like opposites. If you increase one, you're going to decrease the other one. And vice versa. If you increase force, you're going to decrease distance. If you increase distance, you're going to decrease force. So if one goes up, the other has to go down. If the amount of energy being transferred, the work is going to be the same. So this will make sense when I give you a context for it. But the main key thing that I want you to understand is that if there's a set amount of energy that we're trying to transfer, force and distance, as one goes up, the other goes down. So force multipliers, we already talked about how it allows for a smaller force to lift something bigger / heavier. Distance multipliers, we don't need to worry about at this stage. At this stage, just know it exists as smaller distance becomes a larger distance. Okay, now here's a context of why this whole work equals force times distance stuff, why it helps you understand how ramps work. So my guy on the left here, he's just trying to lift this box straight up. Because the weight of the box is 1,000 newtons, and he's trying to lift it straight up, well, the force that he needs in order to lift it is going to be 1,000 newtons. Well, it technically has to be a little bit more than 1,000 newtons, but 1,000 newtons. And he's trying to lift it up a certain amount. So let's say he tries to lift it up 2 meters. His work, his energy that's transferred is force times distance. The force is 1,000, because that's the weight, times by 2. So his work that he's doing is 2,000 joules. He's transferring 2,000 joules of energy in order to lift this block. Now let's go to picture number 2, where now he has a simple machine, a ramp, in order for him to lift it. It's going to be lifted up the same height, so overall the box is going to be getting lifted up an overall height of 2 meters. So we still want 2,000 joules of energy to be transferred to the box. Its weight is still 1,000, but in this case, okay, because we've increased the distance we're working with, we still want it to gain 2,000 joules of gravitational potential energy. Because we have increased the distance that the force is acting, it's become 4 meters now because our ramp is overall a larger distance than our 2 meters of just going straight up. Because our distance has increased, our force has decreased. So it becomes 500 newtons of force instead that he needs in order to lift this block rather than the 1,000 newtons before. And the reason why is because back to this work equals force times distance equation, if you're increasing the distance, you're going to be decreasing the force that's needed. And because the energy that's transferred is going to be the same, because you're only lifting it up a particular distance, you're only transferring a particular amount of gravitational potential energy. That's why that relationship is important. And we take advantage of this when designing these simple machines to allow us to be able to use a smaller force to lift something that is heavier. Okay, now looking at some pulleys then. Once again, we're trying to lift something. So there's 3 separate pulleys here that we're going to analyze. Pulley number 1, pulley number 2, and pulley X, Y, and Z. Now, what we're trying to lift is something that weighs 100 newtons. So we have these weighing 100 newtons. If we just had this one simple pulley here, which is just a rope, we need obviously 100 newtons of force to lift something by 100 newtons. Technically, yeah, we need a little bit more than 100 newtons of force to lift something 100 newtons, but essentially that's what it is. However, if we were to, once again, just like we did with the ramp, increase the distance that we're lifting it through, that means we have to use a lesser force. Now notice that with this set of pulleys, we've doubled that rope length by doing a little loop around. We've doubled the length that the rope is moving with, and we have to pull it further, but we have to use less of a force. So because we did this, like we doubled the length here, we halved the force that we need. So it went from 100 to being 50. And then when we quadrupled the length, we lowered the force that we needed even more. So once again, pulleys are also force multipliers because it is allowing us to take a smaller force, such as 25 newtons, to be able to lift a larger force, such as 100 newtons. And this all goes back to this work equals force times distance formula, where if you increase the distance, you are lowering the force that is required of you. Okay, so a bit of a short one today, but there was not much left in the topic for you to do. So on the website, which I'm going to link, there is practice. So on the left-hand side, we have a sheet for you. On the right-hand side, at the very bottom of my PowerPoint, is the answers to that sheet, essentially. So have a go at the sheet first, and then check your answers. And then once you're done, have a go at answering the quiz that I've put up on Show My Homework. Unfortunately, I can't go back and edit any questions, but a mistake was spotted where I had accidentally selected the wrong answer to be the correct answer. I had mentioned it, I left a comment on Show My Homework to mention which one it was. It's the one about mean speed, so apologies for that. But the main key thing is, click on that sheet, click on that link that I just sent, have a go at those problems. At the very end, we do have some questions and answers for you, and then have a go at the quiz. And if you've already done the quiz, that's fine. You can have up to 3 tries, so you can have another go as well. All right? Okay, right, so have a good rest of the day, guys, and enjoy your summer break. You guys really deserve it. Okay. Bye.